Here we're just supposed to label, so this is easy enough. The mean is 22 with a standard deviation of 6, so this is going to be 28 up here, this is going to be 34 right there. 2 standard deviations is how far we're told to go. 16 is down there, and then 10 is here. Now, just a quick recap of what we know about the empirical rule, and this is normally distributed. I think it's important that we talk about the little sections. 68% fall within 1 standard deviation, which means this is a section that's 34% or 0.34, because together they give you the 68%. If you go 2 standard deviations, that's 95%, right? Well, 95%, if you take away 68 from 95, you end up with 27. Okay, so 27 is in these zones here, but split that in half, you get 13.5. So 13.5 is in this little section here, and 13.5 is in that little section there. Well, that leaves us with 5% unaccounted for out here and here. Okay, you split that in half because this is symmetrical. Then 2.5% or 0.025 is located in that zone. Same thing, 0.025 is out here. So if we want to identify 20% of students are lower and 80% are higher, well, 20% or lower means we're going to include as many of these numbers as we can. 13.5 and 2.5 give me a total of 16%. So the 16 is actually the 16th percentile. Don't know if that meant to be confusing or not. So 20, the solid line that we're going to do just has to be to the right of 16, okay, which is the right of the 16th percentile. So the 20th percentile is just going to be a little above that. It's obviously below 50%, but above 16%. So there's that. Moving on to 11, researchers randomly select 550 people between these ages on a study that affects the exercise length of time, sleep at night. Subjects were randomly divided into 2 groups. Half the subjects were told to exercise for 30 minutes per day, and the other half were told to refrain from exercise. Okay? Randomly selected from the population of people who were between 40 and 70 years old. Okay? Then they were randomly divided into 2 groups. Half of them told to exercise for 30 minutes. The others said refrain from exercise. Average amount of sleep of the group was 7.5 but was only 6.2 for the group that refrained from exercise. So what's the most appropriate conclusion that can be drawn? Well, if we look at our day of notes that basically covered the scope of inference, what can you do? If you're randomly selecting from the population of interest and you're randomly assigning treatments, you can talk about the population and you can establish cause and effect. Both of those things, the word random has to be connected to both to be able to do all those things. However, we can't say it's true about everyone in the world, just people ages 40 to 70. So we don't want to say that no conclusion can be made. But because they were randomly divided into groups, we can make conclusions. So that's out. Exercising causes an increase for all people, not so much. Causes can be made, but causing exercise causes an increase in average amount of deep sleep for that group of people, and that's exactly what's going on here.